This is a story about a technology that was completely ignored for decades. A technology that, when it finally got the attention it deserved, it changed the world. It's the story of deep learning. It all started in the 1950s with the birth of artificial intelligence. In those early days, AIs were basically just programs that were really good at solving logic puzzles or playing games like checkers. But as the years went by, researchers started to think bigger. They wanted to create something that could understand natural language, recognize faces, and even drive a car. But as they worked on these more ambitious projects, they quickly realized that the techniques they had developed weren't good enough. They needed something more powerful. Enter deep learning. Deep learning is a type of machine learning where computers learn from data using artificial neural networks. These networks are inspired by the neurons in our brains, and they remade up of layers of interconnected nodes that process and transmit information. Unlike traditional machine learning algorithms, deep learning algorithms can learn complex patterns and representations of data without human intervention. This means that they can tackle problems that were previously thought to be too difficult for machines, like understanding natural language or recognizing faces in photos. But despite its promise, deep learning wasn't immediately embraced by the AI community. In fact, it was largely ignored for several decades. There were a few reasons for this. First, deep learning algorithms are complex and require a lot of computing power to train. Back in the 1950s and 60s, computers weren't powerful enough to handle the massive amounts of data and computation required for deep learning. Second, deep learning algorithms are prone to overfitting, which means that they can learn the training data so well that they are not able to generalize to new data. This problem has been largely alleviated in recent years thanks to the development of new algorithms and the availability of large labeled datasets. And third, deep learning was considered too similar to the then popular expert systems, which were rule-based systems that were developed by hand. As a result, deep learning was seen as a dead end, and funding dried up. It was on until the 1980s, when expert systems started to fall out of favor, that deep learning got a second look. In the meantime, research on neural networks continued in some universities and labs. But it wasn't until the 2010s that things really started to take off. You see, the 2010s was a time of rapid change. We had more data than ever before, and the computers to process it. Advances in hardware and software made deep learning algorithms faster and easier to train. And most importantly, there was a growing recognition that deep learning was more than just a research curiosity. It was a powerful new tool that could be used to solve real-world problems. Let me give you an example. One of the most famous examples of deep learning in action is the ImagineIt project. ImagineIt is a massive database of labeled images that was created in 2009 with the goal of advancing the state of computer vision. Every year, a competition is held where teams from around the world come together to see who can develop the best algorithm for classifying images. For years, the top spot on the leaderboard was held by human experts. But in 2012, everything changed. That year, a team from New York University used a deep learning algorithm called AlexNet to enter the competition. AlexNet was a convolutional neural network, which is a type of deep learning algorithm that's particularly good at processing visual data. It was able to achieve an error rate of 15.3%, which was nearly 10% lower than the previous record holder. This was a watershed moment. It showed that deep learning algorithms were capable of matching human performance on a challenging task. Since then, deep learning has become one of the hottest topics in AI research. There have been breakthroughs in areas like natural language processing, speech recognition, and robotics. Deep learning algorithms have been used to develop systems that can understand and generate human-like text, recognize faces in photos, drive cars, and much more. So what makes deep learning so special? Why has it been able to achieve these amazing results where other approaches have failed? Well, there are a few reasons. First, deep learning algorithms are highly adaptable. They can learn from data with a wide range of qualities, and they can handle missing or incomplete data. This makes them ideal for real-world applications where data is often messy and imperfect. Second, deep learning algorithms are very powerful. They can learn complex nonlinear relationships in data, which allows them to model complex phenomena. Third, deep learning is highly scalable. This means that as more data becomes available, deep learning algorithms become more accurate. This is in contrast to traditional machine learning algorithms, which often plateau in performance. Finally, deep learning is highly parallelizable, which means that it can take advantage of the massive parallelism of modern GPUs to train models faster. The rise of deep learning has also been helped by the increasing availability of labeled datasets. Labeled datasets are datasets where each data point has been labeled by a human expert. This makes it easier for machines to learn because they do and have to spend time figuring out what the labels should be. Some of the largest and most popular labeled datasets include ImagineIt, which we mentioned earlier, and Common Voice, which is a collection of over 40,000 hours of labeled speech data. Of course, deep learning is not without its limitations. One of the biggest challenges is that deep learning algorithms can be difficult to interpret. This means that it can be hard to understand why a deep learning algorithm makes a particular prediction. This lack of interpretability can be a problem in areas where safety and reliability are critical, such as in healthcare or autonomous vehicles. Another challenge is that deep learning algorithms require a lot of data and computing power to train. This means that deep learning is not feasible in areas where data is scarce or computing resources are limited. Despite these challenges, deep learning has come a long way in the past decade, and it's likely to continue to grow in popularity. As data becomes more abundant and computing power becomes cheaper, deep learning will be able to tackle even more challenging problems. So what does the future hold for deep learning? Well, one possibility is that deep learning algorithms will become even more accurate and powerful. This will allow them to be used in areas where they're currently not feasible, such as in drug discovery or materials science. Another possibility is that deep learning algorithms will become more interpretable. This will make them more trustworthy in safety-critical applications. Finally, it's possible that deep learning algorithms will be integrated into other AI systems. This could lead to the development of truly intelligent machines that can understand and interact with the world in a human-like manner. Deep learning is a powerful new tool that's transforming the way we solve problems and automate tasks. From image classification to natural language processing, deep learning algorithms are achieving state-of-the-art results in a wide range of applications. While there are still challenges to overcome, the future of deep learning is bright, and we can expect to see even more amazing breakthroughs in the years to come. If you enjoyed this video, please like and subscribe to stay updated on our latest content. Thank you for watching, and I'll see you next time.